Okay, so today then we'll look at basic probability. It's an intermediate tier. You can see now like D and E grade stuff now. So it's like the lower end of intermediate tier and things that we really need to know to build that foundation to really understand probability. Okay, now we look at this in Key Stage 3 as well. So Year 8. However, we need to know this information before we can progress on. So basic probability. Now probability is the chance of something happening. So as you can see now, I've got this bag here, okay? You have to imagine this bag is completely opaque. You can't see through it. You have to select one of these counters at random and they all have the equal chance of being selected, okay? None of these colours stand out more than any others. They literally have exactly the same chance of being selected. So we are going to find the probability of selecting one of these colours in this bag here. So if I said the probability then of a yellow counter, again, every colour has the exact same chance of being selected. So now when we write a probability, we can write them either as fractions or as decimals. Now normally, and 99% of the time, we write them as fractions. However, it can be given to you as a decimal, and especially if you have to calculate other things, which we'll see later on, we tend to use decimals a little bit more there, especially with tables. So let's look at this then. So the probability of selecting a yellow, I have got 1, 2, 3, 4, 5, 6 yellow counters in this bag, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 6 out of 21. You don't have to simplify, so leaving it as 6 out of 21 would suffice. So this line here for the fraction, when we're writing it, think of saying out of. Okay, so 6 out of 21. And then that 21 then, well, we had 21 counters here. So this 21 is our total possible outcomes. When it comes to selecting these counters, it could have been any of those 21, so 6 out of 21. So let's look at the probability of selecting a green counter. So let's count the greens. I've got 1, 2, 3, 4 out of 21. So then if I looked at the probability of selecting a black counter, I've got 2 out of 21. Okay, so that's a very basic probability of selecting counters. We can now combine some of these outcomes. So I could have the probability of selecting a yellow or green. So the probability of yellow would be 1, 2, 3, 4, 5, 6. We've got 6 out of 21 for my yellow. And for the green, I've got 1, 2, 3, 4. So the probability of selecting either a yellow or a green counter would be 10 out of 21. Because there are 10 counters in here, which either yellow or green, and obviously, bottom of the fraction, total possible outcomes. Okay. So, how about now if I said the probability of selecting not black? Okay, now we know there are 2 black counters. So, the ones that are not black would be 19 out of 21. So we're looking at the remainder, the colours that are not black. How about then probability of selecting an orange colour? Well, there are no orange ones there. So when things are impossible, we have 0 and only 0, not 0 out of 21, because that would indicate that there are orange ones included in this 21, 0. Think of a number line of a probability scale. If this is impossible, this is certain, obviously the middle line would be even chance. Impossible would be 0, certain would be 1, even chance would be 0.5. So then impossible is 0, but then if I said what's the probability of selecting a red or a yellow or a green or a black, so all of the colours, obviously it would be, so the probability of all the colours would be 21 out of 21. Now your fraction skills, 21 out of 21 is 1 as a whole number, because that's any of those. Okay, you could select any of those, so maybe that shouldn't be all, that should be any. To get 21 out of 21, it's going to be 1, because it's certain it's going to happen. You are going to select any of those colours. So, with a fraction, a number out of your total possible outcomes. But as I said, you could have these with decimals. So this is a completely separate bag now. They haven't given you the bag, they've just given you a table. So I've got probability of selecting a green counter to be 0.3. We've got nothing here for the blue. Red is 0.1 and black is 0.4. Now, with our number line, certain, we use the number 1. You can see here we have only got 4 colours. So for me to select one of these colours, okay, as you can see, 0.3 for green, 0.1 for red. If we add up all 4, because I've only got 4 possible outcomes, they must all add up to 1 or 1.0. Therefore, we can easily work out this missing gap. So I'm going to add up these 3 here. So 0.3, add 0.1 is 0.4, add 0.4 is 0.8. So then if I had 1, subtract 0.8 to find the gap, 10 take away 8 is 2, 0 take away 0 is 0. So therefore, I'll even use a blue pen for 0.2. So the probability of selecting a blue counter would be 0.2. They all add up to 1, so therefore that fills in that gap there. Now, these numbers could be 1 decimal place. They could also be 2 decimal places. That could be 0.21. This one could be 0.18. This one could be 0.39. And I'm going to work out this missing gap. Well, again, we will just add them up to what we have here. 1, 9, 18, 2, 3, 4, 5, 6, 7. Take that away from 1, 0.78. We've got a gap here and be a place value holder. Right, so now I've got to start borrowing from here to then make sure I've got a 10 then as my top value. So then 10 take away 8 is 2, 9 take away 7 is 2, 0 take away 0 is 0. So therefore this gap here could be 0.22. So you could see 1 decimal place, could see 2, could even see a mixture of them both. Okay, so with this question here, it doesn't say how many counters are in the bag. So you could have a question that says, fills in the table for you, telling you the probability of selecting each counter. Then it says, in the bag, there are 50 counters. We can now use that to calculate how many of each counter are in the bag. So, if I wanted blue, I need to find how many blue are there. But if there are 50 altogether, we now need to use that to calculate how many for each bit. So, 0.2 is our probability of selecting a blue of 50. Of in maths is multiply, 0.2 times 50 is 10. If I wanted 0.1 for red, if I've got probability of selecting a red would be 0.1 out of 50 would be 5. Okay, all I've done here, I've used a bit of times table knowledge. I'm using multiplying decimals in order to calculate these. That's all it is. You'll find some questions further on then, you might have a combination of the two, but remember, of is always times. So, basic probability, something out of something. Be careful with your not rule. You could count up the ones that are not black, or just count the black and then take it away. Remember, impossible is always 0. Your number line, impossible is 0, certain would be 1, even chance 0.5, and some of these questions you find to draw an arrow of where it would be. Obviously, roughly, you get a mark for a bit of leniency either way. You could have a table, we've got to find a missing value. Remember, they all add up to 1. Put that here. All decimals add to 1. And if you're told, how many counters are in the bag altogether, use that with your decimals by multiplying to find out how many of that colour counters are in the bag. So in this bag, if there's 50 altogether, using this probability, we know there are 10 blue counters. We know there are 5 red counters. Sometimes you're allowed a calculator for it, sometimes not. So it's a good way of getting used to not using a calculator for these questions. Hope it helps.